In this tutorial, I'll show you how to create your own Shiny web app, and we'll start by using the default Shiny web app that comes standard in RStudio and Shiny package when you launch it for the first time and every other subsequent time. After that, I'll show you an example of a more complex version of a Shiny web app that hopefully can serve as inspiration, as well as show you some of the other features and ways in which you can specify your server logic as well as your user interface specifications as well, and define that to however you'd like it to look. Now note that this is not going to be an exhaustive and an extensive tutorial, and if you need a crash course on what Shiny is and an introduction to Shiny, then I recommend checking out my video called Introduction to Shiny, and you'll see a link in the bio here, or the description for this video, where you can access that and learn more about the basics of actually setting up your first Shiny web app, as well as learning how to publish and deploy it. So I won't focus on how you actually go about publishing a Shiny web app in this tutorial. You'll have to check out the Introduction to Shiny lecture to learn more about that. Okay, so as you can see here, RStudio is open, and if you have a relatively recent version of RStudio downloaded and installed in your machine, it's relatively easy to open up your first Shiny web app script window, and it'll look a lot like a standard R script window that you're probably already familiar with. And so you actually follow a very similar process. So just go to File, New File, and you can see maybe you're used to going to R script or R notebook or R markdown. Well, let's skip on down here to File, New File, and Shiny web app. Okay, you'll see that the next thing that comes up is that we need to come up with some kind of application name. So for this really simple example here, I'm just going to type in practice, just all lowercase though. And this is going to create a folder actually within a directory that I specify. And so also note that they do ask for an application type. The default is a single file. So you'll have your user interface and your server scripts are going to be within the same file that'll be called by default app.r. You could also click here to do a multiple file option where you have two separate script files. It's really up to you. When you're starting out, I actually recommend using the single file app.r default bubble here. Okay, the next thing that you'll do is you're going to create this application within that directory folder of your choosing, and you can go to Browser and scroll down here. I'm going to go to my H drive, our workshop folder, and I'm going to create a, I'm going to put this practice folder here. Okay, it looks like I already have something called practice, so I'm going to call this practice_2 here. And so you specify what working directory or path directory you want this folder practice_2 to be located in. And once you're done with that, click create and you're ready to go. And so as you can see, by default, the Shiny web app, that script that comes, as I mentioned, by default when you open this up in RStudio using File, New File, and Shiny web app is this. And so this is really awesome. They provide you with a sample script here, and this you can actually run this to see what it looks like, and I'll show you that in a second, as well as they point you back to the shiny.rstudio.com website to get more training. They have some more extensive tutorials there, as well as a really cool gallery feature where they have a number of publicly available dashboards and Shiny web apps that you can access, as well as not only interact with those that others have created, but you can also look at their script that they use to write their Shiny web apps as well. So you can get some inspiration at that level, more technical level as well. So let's just go ahead, and before we even break down what this script is doing, let's click Run App here. And so this will open up a window here. You can also open it up into a browser if you'd like as well. It's really up to you. And the next thing that we'll do is we are going to play around with, this has a very simple user interaction feature here, an interactive feature, or reactive rather. And that is you can slide this around to change the number of bends or columns or the number of ways in which this the levels of the data are grouped here for this variable x. Okay, so this is just a histogram here. So you could do all the way up to 50, all the way down to 1, which provides very little information about the shape of distribution. Okay, so this gives you an idea about how you would go about, or what a very simple dashboard or data visualization that's interactive and dynamic in nature, developed using the Shiny web app package as well as script from R, what it can actually look like. Okay, so you can click stop here to stop that from running. So let's break down just what this example is doing. So first, right off the bat, you'll see that library Shiny is specified here. So it's just calling up the Shiny package, which is Shiny lowercase. You likely have this already automatically installed, but if you don't, you just would do install.packages Shiny to get it installed on your machine or to update it. Okay. Next thing you'll notice is let's focus on this first chunk of script or code here, which is all the way down to here, which is defining the user interface or the UI. So for that old faithful example that we saw, first we specify a function called user or fluid page here. So we're setting up a fluid page. And this is a function from the Shiny package. And we're using the left-handed arrow here to name everything that we do here. All these operations and definitions are going to be tied to an object that we'll call UI. I recommend just keeping it as is. UI for user interface, lowercase u, lowercase I. Then you'll see within the fluid page function, we can specify using the title panel function from Shiny what we want the title panel to look like. So you remember the title panel was what we saw. Let's see. Oh, forgot to save it. You have to save it each time before you run it. So let's run the app and I'll just quickly show you. So this is the title panel here, is the old faithful geyser data. So that's the title we can put. You could change this if you wanted, just change whatever is in the quotation marks. You'll see next we have the sidebar layout, okay? And so the sidebar layout is this section of the window here. And you'll see that that changes depending on how big of a window we have open. So this is going to be reactive in that sense too. So it's not fixed to a specific location when we use that particular function. It'll change its location based on the size of the window you have open. And so within the sidebar layout, we can specify the sidebar panel function here. And this is where we can create an object and an input object specifically until you'll see slider input. So if you see right here, how do we actually create this slider here? It's interactive. This is an input. So the user gets to put their input here of, oh, we want there to be 39 bins or 20 bins or whatever the case might be. This is how you do it here. So the first argument is specifying an object name. In this case, this person who created this example Shiny web app just called this bins all lowercase. You could call this whatever you want here in the quotation marks. Just you're going to have to reference it again later on. And then as the next functions, you specify, for example, the title for it. So the number of bins that you want, this would be number of bins, which we see right here, number of bins. So that's the title. And then we want to set here the minimum and the maximum, so 1 and 50, as well as where the default location of this slider is going to be, okay? And so as you can see, the minimum was 1, the max was 50, and the default location of the slider is 30, okay? So you can set wherever you want it here. You could change this to 25, and let me actually close out of this, and let's change this to 5, and let's say minimum of 5, max of 25 bins. Now let's click save and then run the app and watch what happens here. Okay, now you see the minimum number of bins we can select is 5, the maximum is 25, and I set it so it starts the low end of that. Okay, so that's an example of just a simple sidebar panel input there. In this case, it's a slider input. And then there's also the main panel. So the main panel, when we look at our app, is this. This is this big space right here. So this is where, in this case, we chose to put our histogram. And you can put anything wherever you want it, and I'll show you how you change that in a second. So for our main panel, we use the plot output function from the Shiny package. And here the person who created this just put dist plot. So this is the name of the output object that they've created here that they're going to reference later on in the server logic. And so you can put whatever you want here. You can name it whatever you want. It's just important that you remember to reference it down below, and we'll go through that in just a second here. But as I was mentioning, you can switch things around. So you don't have to put the slider in the sidebar panel. In fact, I'm just going to cut this from here, and then paste it in the main panel. And then put the plot output. Let's put that in the sidebar panel. Let's save it and click run. Okay, so now we've switched things around here. So now the main panel has the slide bar and the side panel has the histogram output. Okay, so now let's go down and see what's happening behind the scenes. Let's talk about the server logic. And this is where you have your R engine running behind the scenes to do any data management, data analysis, or data visualization that you need to take those inputs and outputs that you've specified up here. So again, the slider input, this is an example of an input. The plot output is an example of an output. Take any of that and bring it to life to create your interactive dashboard or data visualization. So just as we did above, we use a left-handed arrow to name this object that's going to contain and define our server logic. And here, I just recommend keeping this the same too. So just keep it server all lowercase. Okay, and we'll end up referencing both the UI and the server objects a little bit later on. And notice that we're creating a function here using the function, as you can see here with function in blue. And we have input and output, okay? So we're gonna be specifying what our inputs and outputs are and what we do with those, okay? So here, in this example, they're starting with the output. So they specify that this output, and they attach the name of the specific output, which is dist plot, which should look familiar. This was this up here, the plot output. They're saying, so how do we determine what that output is? Well, here, they use the render plot function from Shiny to render a plot. Okay, so there's different types of render functions that you can use. There's render text and render plot and so forth and so on. And I'll show you those in a more complex app a little bit later on in this tutorial. But let's just focus on the basic logic here of what's happening. Okay, so basically they're just calling up a sample data frame here. And this sample data frame comes standard with either the Shiny package or maybe it comes standard with RStudio. But you can just call it up really simply by if you want to see what these data actually look like, just type in faithful here in your console. And what you'll see is this is just a very simple data frame here. And it is just the number of eruptions of the Old Faithful geyser in Yellowstone National Park in the United States and Wyoming. The number of eruptions as well as waiting. I assume this means how long you wait between the eruptions, probably in minutes, probably in minutes. And what they've selected here is they've noted that they just want the second column here. So how long you wait, okay? And you can see this called up here if you want confirmation. That's what they're calling up. They're just using matrix, yeah, so it's the wait times here. So you just see these listed out in an array there, or a vector. And they're just naming this X. They could call it whatever they wanted, but here they're just creating an object just like you would in creating a regular R script. They're doing the same thing here within this render plot function. And then you'll see that they reference this vector here that they've named that contains the waiting times as in terms of creating a sequence of values that ranges from the minimum of whatever the minimum is of this vector right here, and which we can actually find out. And so these are all just base R functions that they're using here. So if we type in min with X as our sole parenthetical argument, we got to specify it first. So let's just specify that, and then let's see what the min is here. The min of that X object is 43, and then they specify that the max value of the sequence will be whatever the maximum value is of that X vector. And then as the next argument in the sequence function, which is again a base R function, it's the length, which is going to be the number of bins plus 1. Okay, so they're specifying the number of bins here. Okay, and so this is where you see we're referencing input and using the $sign to attach a specific input that we created or noted in our user interface portion of the Shiny web app above. And so here you can see we created an input that is specifically a slider input here and had its own specifications. and then we added 1 to that value. And so now we have 2 objects that we can reference, X and bins. And then here we come down, here's the standard histogram object from base R. And we can we first reference the vector or the variable. And so here it's just this X object of the waiting times. And then how many breaks we want. And breaks is just another way of saying bins. And so we can put the bins, breaks is equal to this bins object here. And then we can specify the color of the bars in the histogram. Here it's specified dark gray. And the border color, here it's specified as white. So really what's happening is this is telling this function that the bins, this is going to be what we're actually, that a user can interact with via the input, which is that slider bar of bins. So that person can change this length.out argument here behind the scenes using this R engine by using that slider bar. So that's how the number of bins here, the size of the bins, is going to be adjusted behind the scenes. Okay, so you can see that this is just very simple. There's just a simple one output that we're really focused on right here, which is just that histogram. And then finally, you'll see at the very end of the script, which again, it just comes in this example by default, is you'll see the function shiny app with a capital A for app. And this is just where you give confirmation that the user interface, what is that object called? Well, we kept it just as it was, which is just UI. So you just say UI equals UI, and the same with server. Server equals server because that's what we named it here. If you change the name of the server logic object or the user interface object, you would just change that here. There's really no reason to do it that I can think of at the moment. So I just keep these the same here. Okay, so that's how you do it. And so like, for example, if I wanted to adapt this and I wanted to say, well, I really want the bars to be blue. So I change call equals blue and click save here and then click run. We should see now that the bars are blue, as you can see here. So this is an example of how you can create these interactive dashboards via Shiny Web Apps here. Okay. So the next thing that I'd like to do is I'd like to actually open up a more complex version of a Shiny Web App. And to do so, I'm going to open up an existing one I have. So I'm going to go to Open File. And here, this is actually the folder I want. So within my R Workshop directory folder, there's a subfolder. And so this was an application folder that I created previously. When I did the same thing that I showed you at the beginning, which is go to File, New File, and Shiny Web App. You get to that window. I called it Differential Prediction, and it gave me the default app, and then I adapted that app.r file, which you can see listed here. And then also you'll see here that there is a .csv data file that I have in this folder, and that is because you need to make sure that all files that you reference within your Shiny Web App need to live in that same folder that you created within the directory you specified. So if I had other data files or things that I needed to reference or read in to the Shiny Web App, they would need to live in this same file here, or same folder here, this differential prediction folder that I created. That's the name of the application. Okay, so I'm going to open up this app. And it's actually okay to have two with the same name. They actually, behind the scenes, they get referenced a little bit differently. Like, so if you went to File and look through your recent files, you'll see that they're named, they'll have a little dash noting what the parent or what the application name is behind the scenes. So this one would be app-differential prediction, for example. But let's just close out this other one that we were working on before, the example one that comes standard in RStudio and the Shiny package. So you'll see that all the same building blocks, and I built this using that template that, that you already saw using the example when you go to File, New File, Shiny Web App. I just used that as the template, deleted some stuff out of there, some annotations they had, and then customized it to my own specifications. Because what's important to note is that they have first what you need, the library function with Shiny package specified, so you need to access that package so you can use all of its functions. And then you have the user interface section where you can define the user interface. Again, I left this as UI, which is just kind of the default mode here. You kept the name of this as just app.r, so didn't change that either. And then if you scroll down here, you'll see for the server logic where I defined that, kept server, the name of the object, the same, server all lowercase. And at the very bottom here, again, Shiny app, that function where you actually run the Shiny app, I just made UI equal to UI and server equal to server because that's what I left the names as here. Okay. Now I'm not going to extensively go through all of the different functions and inputs and outputs that I've specified here, but I want to show you, just give you a glimpse of all the different things or some of the different things that you can do with Shiny web apps. So I think a good place to start is just let's see what the end product is here. So I'm going to run this. Okay, it might take a second for this to load. Okay. And so here you can see, sometimes it helps to open in the browser. Here you can see there's some overlap here. Usually the browser gives you a more realistic depiction of what this will actually look like. But what you can see, this is interactive and dynamic. So let's say I want to change, this is for differential prediction by selection protected class. And what I'm doing behind the scenes is really eventually running a moderated multiple linear regression model where the predictor variable is a selection tool or assessment that an applicant might take. So here you have two choices, interview or work sample. The criterion is the outcome variable. Typically, this is performance evaluation or some kind of performance indicator variable like sales revenue generated by someone, if this was a sales position. And then also a moderator variable, which in this case is a protected class variable. And so here we have age of the applicant, gender of the applicant, and race of the applicant here. And so here's some basic distributions, frequency, bar chart, histogram, and so forth, to just get an idea of both the selection tool predictor, as well as the criterion variable, as well as in this case, is dichotomous protected class variable for age. And you can see if you switch these around, if you change the different variables in real time, R will update these. And I created all these using ggplot2. If you come to scatter plot here, this is where you'll find the scatter plot, and you'll see that this has whatever variables you selected over here. So we have the sales as the outcome, work sample as the selection tool, and protected class as the categorical moderator variable. And so it's age here is the selected one. You can see over 40 years, under 40 years of age. And so this is just a scatter plot where you can start to get a glimpse at, okay, do we think that there might be differential relationships here? Or is the relationship, in other words, between the selection tool work sample and the criterion of sales, is that relationship contingent or conditional upon levels of the protected class variable we've selected, where the levels are over 40 years old or under 40 years old here? And so again, this is interactive, so you can change the variables around and it'll update in basically real time. This is a ggplot2 scatter plot here. Next, you can come to the model summary section. And this is where you can see above, behind the scenes, the R engine ran the LM function, which is the linear modeling function that you would use to run a linear regression model, such as a simple linear regression model, multiple linear regression model, or in this case, a moderated multiple linear regression model. And so what you'll see down here, if you go to the coefficient section, you'll see the intercept, the work sample, which is our selection tool variable, the age, which is the protected class variable we selected, and the interaction between the work sample variable and the age variable here. In this case, the p-value is greater than 0.05, so we typically say that that is non-significant based on the conventional alpha level of 0.05. However, let's play around with this again. Let's switch the protected class variable to gender. Okay, still not significant. You can see this is updating in real time. Let's switch the selection tool, but keep everything else the same, to interview. Okay, so as you can see, R behind the scenes is running this in real time. And now we see that the p-value for the interaction, now we see a significant interaction, which would give us interaction of slope differences in terms of differential prediction by protected class here. Or in other words, evidence potentially of unfairness or fairness bias, or you could call this prediction bias here, okay? And you get down below, you get the standard output with the LM function when you would use summary, summary LM, whatever the model object is, you get your R squared and so forth as well. Okay, so for this one, since we found a significant interaction, let's go to the next tab here. And this is where we're gonna get an interaction plot. So this will be the same scatter plot we would see over here, okay? But this time it's overlaid with the simple slopes. So what that means is that in this case, the selection tool in relation to the criterion, so this is our predictor and outcome variable, which in this case is interview and performance evaluation, by levels of the protected class variable of gender, so man and woman here. And here you can see mostly what looks like for women, it's a positive slope for selection tool in relation to the criterion. And for men, it's like either a flat slope or slightly negative slope. So either slope of 0 or maybe slightly negative there. And so the next question would be, let's go to this tab, simple slopes. Are these slopes significantly different from 0? And if so, which ones? And so here you can see that the simple slope of the interview of interview in relation to the criterion of job performance when gender is woman is 0.259. The p-value is less than 0.05, which would signify here that this is statistically significant. So it's saying that this slope right here that looks positive for women is statistically significant. However, for men, that their corresponding slope is non-significant. The p-value is greater than 0.05, our conventional alpha level for a two-tailed test. And so this gives us a little bit more information about how to interpret this. Okay, so this is what's happening behind the scenes, and you can see everything, it can be updated in real time here. Okay, so it's a very cool feature of Shiny Web Apps. Okay, so let's now just very quickly break down a few examples of things you could consider using in your own Shiny Web App when it comes to user interface, as well as for the server logic. So here you can see, as we saw before, you start with the fluid page. This is typically what we want. The title panel, this is what we can put a title. Here I called it differential prediction by protected class. And then I chose to put in the sidebar layout and the sidebar panel, I chose to put these different inputs where these are these inputs right here. So where the user can come and select these and change these inputs to affect the analyses and data behind the scenes here. And so here for the select input, this is instead of doing a slider, this is select input. This is how you can do a drop down. And I first need to come up with some kind of name, so the input ID that I can reference in the server logic later on. Here I call it outcome because I could have called this criterion too. That might have made more sense given that I label it criterion, but I just left it as outcome here for outcome variable. And then because this is a select input, you have to give the choices. So here I'm saying that this is the label that I want to be displayed for the user. So I want the user to see either performance or sales, but I need to say what is the corresponding name of the variable that this corresponds to in the underlying data frame or data that this is going to reference. And that happens to be for the, we're going to be referencing later on in our server logic, this file called MMR, all capitalized. And within that, there's a perf eval variable, and it corresponds to performance levels. And then sales happens to correspond to a variable called sales with a capital S as well in that data frame. But here we're just putting these inputs, but these would need to match whatever is in the data you subsequently reference, or you need to rename the data so that the column or the variable names are consistent with these. Okay, and then you can put default, what do you want selected? Well, I just want the first one to be, so when I open up this and run this web app, I want the first one, performance, to be the first one that shows up here, okay? If I had selected 2, then sales would show up by default, okay? And then here I do the same thing for the predictor variable with selection tool, okay? And I do the same thing for the moderator, which is our protected class variable. You can see the choices here. So same thing, using the same select input function from the Shiny package. And now come over to the main panel. So now I'm specifying the user interface for the main panel. And it can get a little tricky here, and you want to be really deliberate about which lines you put your brackets as well as your parentheses on, so you don't lose track of them, because it's easy. You're nesting functions within functions, often within these user interface and server logic objects that you're creating here in a Shiny Web App. But so here I'm saying let's use the main panel function from the Shiny Web App and specify what we want in that main kind of central panel within our user interface. And so I'm going to create a set of tabs, as you saw before. And so I'll use the tab set panel function from the Shiny package, and I'm going to call this input here, or rather this output here, I'm going to call this tabs, okay? And this is going to include this is not really truly an input or output. We'll get to those in a second, where we specify what those are. This is just essentially a feature of the user interface. Okay, so here we're going to name the first, using the tab panel function, name what we want that first tab to be called. I just called it distributions. This should look familiar here. Oops. So remember, I called them distributions, scatter plot, model summary, interaction plot, and so forth. Okay, so that's what I'm creating here. And so for that first distributions tab that I'm creating, I'm using the fluid row function here because I have multiple rows of distributions I want to display, both histograms as well as that frequency bar chart as well. And so you can adapt these column widths here to change the width of essentially how much space each one of these plots will take up that we're creating here using the plot output function. Okay, and so you can think of there being 12 spaces per line. So if I want three plots to be on the same line, I would space these out as 4, 4, and 4, which adds up to 12. And in the second line, I just want 2, so I'll do 6 and 6 here. Okay, and so I have to come up with an output object name for each one of these. So I'm calling the first plot is going to be distribution 1 all the way to distribution 5 for the 5th plot object. Okay, and then on to the next tab. Here's where I specified that I want what the and by fluid row, this means that these will wrap around and change and so forth, depending on the size of the window or the browser that someone's using. And so here's another input object here, or output object rather, the scatter plot, summary, etc., etc., etc. So I'm just specifying all the tabs here. So I think that's good enough to kind of give you a lay of the land for the user interface. Now let's talk about the actual server itself. Okay, so the server logic that we're going to define. So again, keep server the same, but now we're going to specify a function, and we need to specify our inputs and our outputs. So here we've said that we're going to call the input, input, output, output. And the first thing that I did here was I set up the data. Okay, so, and this is also where I just list out all the functions that I'm going to need throughout this particular server logic to bring everything to life, to run the R engine. And so using the read_CSV function from the reader package, I read in that data file. Remember, this data file needs to reside in the same directory folder as you saw, which here earlier, as where the app is located within that application folder. Okay, so here I read in the data. And then I just do some grand mean centering and so forth, which is happening here. Just grand mean centering some of the predictor variables here that are continuous. And then with the moderator variable age, I actually dichotomize it to be more consistent with federal law in terms of people being over the age of 40 at the federal level protected under the Age Discrimination in Employment Act. And so I specify that, and then I drop just preemptively any cases within the data frame where they have any missing data. So I'm doing a list-wise deletion here. And then I'm just noting that this is a data frame and not a tibble here. So I'm just redoing this as a data frame object. And so here's the data frame object that we'll reference subsequently in some of this output here, or some of this server logic. And so here, first above here, I specified that there was going to be a histogram a distribution object that was going to be called distribution 1. And down here, this is where I'm specifying what that output's going to look like. And so I need to say that this is output $, and the exact name of that output object I created above here using the plot output. Okay, so distribution 1, and I'm going to use render plot function from the Shiny package. And here I just give a Shiny script. Okay, I give a Shiny script here, and this Shiny script is just creating a histogram here. Okay, I do the same thing for the bar chart, the third distribution, histogram. So these are all the outputs that for that first tab, that distributions tab, all the way to the 5th one here. And then here's to create the scatter plot tab. Here is the output scatter1 that we referenced above or created above in our user interface, the UI object. Here we're referencing this as an output, so what we're going to specify for that. And then the next tab, if you remember, is the summary tab, and this is where it's the model summary, and this is where we actually run our linear regression model. And notice the notation I'm using here. So I'm using the LM function, so this is just from base R, and I'm naming this model object, this linear model object, mod1, which I'll reference here subsequently. But notice that for the outcome variable, I'm referencing the name of the data frame, and then using matrix notation here to say that I want the the column that contains whatever outcome variable the person selected. Okay, so remember, up above here in the user interface, I specified with the drop-down menu, the select input feature of the user interface, that people could select either performance or sales. Okay, so I need to tell, and this is how it's reactive here and interactive, I need to tell the LM function that you need to input here whatever outcome variable that the person selected. And the same to the right of the tilde, whatever predictor variable and whatever moderator input variable, which is the protected class variable someone selected. Okay, so I'm using this bracket notation here. Okay, there's some other ways that you can do this, but this is one of the, at least I found, one of the more straightforward ways to do it. And then I'm specifying what I want the model names to be by default. I'm just saying let's call the intercept in the model coefficients to be called intercept. And I'm going to call it interaction just interaction instead of the default, which would be to put the name of the input predictor variable, colon, the name of the input moderator variable, which can take up a lot of space. I'm just going to call this interaction here. Okay, so that's all I'm doing there. And then summary. So this is just saying what this is going to print. It's going to render print. So instead of render plot that we saw before, it's going to render print the output of this LM function, the linear modeling function for linear regression, via the summary function, this model object. It's just going to print what you would normally see in your R console. And this is what you see here under the model summary tab. So it'll take a second to load. That's just, it's printing what you would typically see in your console. Okay. So here, this is what I was meaning in the coefficients. I renamed this intercept and this interaction here. Okay, and so here's the interaction plot. This gets a little bit more complicated here when we move on to the simple slopes. So to actually specify those, I calculated the simple slopes by hand as opposed to using someone else's function here. And so this is what's happening behind the scenes. I won't walk through all of the steps here I used. And then I used some if and else if logic here to refine the simple slopes output. Okay, it was a little bit trickier to get this to work. So let me show you what I'm referring to here, this last tab for the simple slopes. Okay, it was a little bit trickier to get it to display the level of the protected class variable, the moderator variable. I wanted it to write out over 40 and this to be reactive and interactive. And to do so, I use these if and else if statements here. Okay. And I'm just saying I wanted to concatenate this all together using the paste 0 function from base R. And that pretty much wraps up the last tab. And then so finally, the last thing is that Shiny app function from the Shiny package, where again, we just reiterate what is the name of our user interface object? Well, we called it UI, so it's UI equals UI. What's the name of our server object? Well, we called it server, all lowercase, so we say server equals server. And then you're ready to run the app here. Okay. Now, if you wanted to publish this, to learn more about how you'd actually go about doing that and how to create a shinyapps.io account so you can start launching some of these and publishing them and deploying them, check out, again, that video that's called, I'll just put a note in here. It's called Introduction to Shiny. And it's a lecture video. I walk through the website and some screenshots for even within RStudio here as well, to give you an orientation to Shiny web apps. And you can find this. This is going to be in the description of this video. And this app here, there's also a link to a GitHub, my GitHub page too, if you want to find this app.r example that I used here, as well as to find this mmr.csv data file that I use in this example. So if you'd like to recreate this and start adapting it and playing around with it on your own, that is also found on the GitHub site, which you'll also find in a link in the description as well. All right, so this was meant to just be a very brief overview of what Shiny web apps are and what they can do. Hopefully by showing you the example one that comes standard in RStudio in the Shiny package, you have a base understanding of what these are and how to interpret them and how to edit them and make them your own, as well as hopefully you can see a little bit more complexity you can add and some additional features such as tabs and so forth that I illustrated in this one that I created here. That looks at differential prediction by protected class using moderated multiple linear regression, as well as estimating simple slopes and plotting the simple slopes as well over a scatter plot. So this wraps up this tutorial on using Shiny